So we have already seen how we can use the task notification feature in FreeRTOS, and in the previous example we have seen how we have sent task notification from task 1 to task 2, but that notification was a very simple mechanism where we sent a notification without passing any value to it. So task 2 was receiving a notification, but it didn't know what it had to do with the notification or what the notification was about, because there was no value involved. But now we're going to look into some other feature of the direct to task notification function in FreeRTOS, and I'm going to use a function called xTaskNotify. Um, Now this function is going to send a notification to my task 2, and there are three parameters to this function. The first parameter is going to be the handler for the task that I want to refer to. So I want to send a notification to my task 2, so I need to use the my task 2 handle. The second parameter is going to be the value that I want to send. So let's say that I want to send the value where my 16th bit is high. Now this is going to take a 32-bit unsigned integer, and I'm going to send one shift left by 16. So just for you to look into this function, if I look into this, I can see that my first value is going to be xTaskNotify, so that's the handler. The second value is unsigned 32-bit integer, and the third parameter is going to be eNotifyAction. So I will also look into the third parameter, and I have these functions available, and I will explain these functions. Let's go back to the main and let's see. So my second parameter will be holding the integer value, the unsigned 32-bit integer value, and my third parameter, as I said, I have a list of options here. The first one is no action. So if I use that, then I'm not going to make any use of that value. So if I don't want to pass on any value, then I can just keep it as as the value as 0, or I can give the values anything. But if I use no action, then I'm not going to be able to read that value. If I use eSetBits, which I'm going to use now, then this is going to set the value with the previous notification value. So now initially the notification value is 0. So if I use eSetBits, what it is going to do is it will take one shift left by 16 and then aggregate it with the previous notification value, which was 0. So it's going to be this number itself. And then I will wait for some time. I will wait for 1 second, and then I will send another notification where I'm going to set my 4th bit high. And then finally I will send another notification where I'm going to set my 20th bit high. So I'm going to send 3 notifications every 1 second and then loop back and repeat the process. In my task 2, I am going to use a function called xTask. Excuse me. Yeah, excuse me for the call. So in my task 2, I'm going to use a function called xTaskNotifyWait, where I shall be waiting for the notification. Now this function has 4 parameters, and I'm going to explain what the first 2 parameters are going to do in a bit. So my third parameter is going to be where I want to store my notification. Now okay, my task 1 has sent a notification and my task 2 has received it, and it wants to read the value as well. So when it reads the value, it needs to store it somewhere. So I'm going to create that variable here, the uint32_t, and I'm going to call that variable as ulNotifiedValue. So in my third parameter, I'm going to pass in the address of that variable, and my fourth parameter is the blocking time. So for how long I want to wait for the notification. So if I want to wait indefinitely, then I'm going to use port max_delay. Now if it gets a notification, then it's going to return a 1 or a PD true, and if it fails, it's going to return a PD false. So I can use that to check if I have actually received a notification or not. So if it equals to PD true, which means that I have received a notification, then I want to print notification mod. I'm going to print the notification value in hexadecimal, so mod #x, and the notification value is UL notified value. Okay, so just to recap of what I'm doing, I am sending some notifications using the function xtos notify for my task 1, and I have these 3 parameters. The first one is the handler, the second one is the notification value, and the third one is the notify action. And in my task 2, where I'm receiving the notification, I'm using the function xtos notify wait, and I have not yet explained what this first 2 parameter does, but I'm going to explain that in a while. Third parameter is where I want to store my my notification value, and fourth parameter is the blocking time. I'm checking if it returns true, which means that I have received a notification, and if so, then I can do whatever I want to inside this if statement. So let's go ahead and let's run this program. Okay, so you can see it prints these values here. Okay, I'm going to pause it and show you what's happening. So first value of the notification that I got is 10000. Now this is equivalent to 1 shift left by 16, and the next value that I'm getting is 1 shift left by 16, and also my 4th bit is high, so I have my 16th bit and my 4th bit high. So I can notice that my previous notification value has not been cleared, so it's still holding the previous notification value. And again, in the third case, I'm having my 20th bit high, and also my 16th bit, and also my 4th bit high. So I have 16th, 4th, and 20th bit high. And then when it follows the the loop again, and it still has the same value over and over again because the bits are already set. So I can notice that the bits are not cleared. So when I'm sending the xtos notify, when I'm sending a notification using xtos notify, I have not cleared my previous value. Now there are 2 ways of doing that. One is, every time I want to send the notification, then if I want to override the previous value, then instead of using eSetBits, I can use eSetValue with override. So if I use that, then I can override the value. Now let's go ahead and let's see how this program will run. Clear the screen. Okay. Okay, so let me reset the processor another time. Okay, so you can see it sends 1 shift left by 16, which is 0x10000. That's the first notification value that I have sent, followed by 1 shift left by 4, which is 0x10, and followed by 1 shift left by 20, which is 0x100000. So now this time, every time it sends a new notification, it clears the previous notification value and sends a new one. So this method can be used to send a new notification value. But let's go back to how it was before, where I am not overwriting the previous notification value. Now here I'm going to explain you what these 2 parameters does. Now the second parameter is going to do almost what we have done right now about clearing the values. So let's say that whenever I get the notification, then I want to make sure that my 4th value and my 20th value and my 16th value are cleared. So I can go ahead and I can do it in this way: 1 shift left by 16, or 1 shift left by 4, or 1 shift left by 20, or one shift left by 30, or I can go on and just give a masking value for almost all the bits. So if I want to clear all the bits, so I can go ahead and put 0x FF. Now what's going to happen is whenever I get a notification, then all the bits that are set to 1 will be cleared. So right now all the 32 bits are set to 1 in this parameter, which means that all the bits are going to be cleared. So if I go ahead and if I run this program, so there you can see this time also it's sending the notification values without holding the previous values. So I'm getting one shift left by 16, then one shift left by 4, and then one shift left by 20, because every time the notification value is being cleared after the notification has been read. Now what about the first parameter? What does that do? It does exactly the same thing as the second parameter, but the difference is it will do the clearing before the notification value has been read. So this is after reading the notification value, and this is before reading the notification value. So if you want to use it, you can use the first parameter as well, but if not, you can just leave it at 0. So this is how you can use the notification feature to send a notification and a value. And practically how I would use this is, let's say if I get a notification on my 16th bit, what I want to do, or if I get a notification on my 4th bit, what I want to do, I can go ahead and I can put an if-else statement, or I can put a switch case. I'm going to use the if-else statement here. So if the notification value has my 16 bit high, so I'm going to mask it with the 16 bit. If it equals to true, then I want to print red. The same thing, I'm going to do the same thing, but I'm going to check if my 4th bit is high. Okay, so if I have my 4th bit set, then I'm going to print green, and I'm going to do the same thing for my 20th bit, which is going to be printing blue. So if I get a notification on my 16th bit, it's going to be red. If it's on 4th bit, it's going to be green. If it's on 20th bit, it's going to be blue. So let's run the program. Let's see how it looks like on the terminal. Okay, so there you can see it's getting a notification on red, then green, and then blue. And since this is in an infinite loop, it keeps on sending these notifications again and again. So this is how you can use the notification feature. And another few things that you can use is you can use a function called xtask notify and query. So it's similar to xtask notify, but I have another additional parameter. So if I use notify and query, I need to use a 4th parameter, and that's going to be how I have the address, how I'm going to pass on the address of the variable where I want to store my notification value. I can do that here. So right now what it's going to do is it will send a notification just like how it did in this function here, but it's going to also take the notification value and store it inside this variable. So you can also find out, okay, what was the value of the notification before, and what you have done with the value now. So it's just like you are doing a query for the notification value. And if you want to clear the notification, or if you want to clear the state of the notification, then you can use a function called xtask notify state clear. So you're going to use that function, and the input parameter is going to be my task to handle. So this is going to clear the notification to its default state, where the value is 0. The notification value is going to be 0, and that's the default state. And And another thing is this function xtos notify and xtos notify inquiry. If you are using these functions from inside of an interrupt service routine, an ISR, then you need to use this suffix in the function called from ISR. You have seen this thing in many other functions as well. So if this is from inside of an ISR, you use from ISR. And the same thing goes for xtos notify inquiry. If it has to be from an ISR, it's from an ISR. Okay, so this is it. This was about using the notification feature in FreeRTOS.